In this lesson, we're going to learn about the next construction, construction 13. It's another triangle, but this time we're asked to construct a triangle where we're told that one of its angles is a right angle. Now, if you recall, a right angle means a measurement of 90 degrees. So if we look at this triangle here, you can see that there is a number of things that will tell us that it is a right-angled triangle. But the most obvious one is the use of the symbolic notation, this little box in the corner, which means that we don't actually have to use any of our maths tools. We know automatically that it is perpendicular, this side that is running along horizontally, and this side that's running vertically up and down. They are perpendicular or at right angles to each other. And we could check that in a number of ways. We could put our protractor onto it, lining up the center mark and the baseline of our protractor. And we do in fact see that it's 90 degrees. Alternatively, we could use our set square or the corner of a page, and we would see that it fits absolutely perfectly with the right angle on our set square, fits in perfectly there with our diagram. So if we're asked to construct a triangle and we're told that one of the angles is 90 degrees, we call this a right-angled triangle. Now in this particular construction, we're also told two side lengths. So this is a very special version of SAS, which we have learnt before. We're told two sides and one angle, but the angle is special because it's 90 degrees. So this construction is actually done slightly differently. And the one side that we're told, so it's given two side measurements, but one of them is very important. And we're going to learn what the name of that side is called. It's the side that does not touch the right angle. So the right angle is here, it's touching this side and it's touching this side. It's not touching this one at all. This is the opposite side. If I was to draw a line through our right angle and go to the opposite side, then we call this length of a triangle, the opposite side to the right angle, a special name. It's called hypotenuse. Hypotenuse. So we're learning today how to construct a right-angled triangle where we are told the measurement of its hypotenuse, the opposite side, and also we're given one other side. It could be this one, or it could be this one. So we have the abbreviation RHS. So we don't use SAS in this case when it's right-angled and we've been given the hypotenuse measurement and we have another side. We call it RHS. Let's check that you understand what we mean by the hypotenuse. Have a look at this triangle that's on the screen. Point with your finger to the side that it is the hypotenuse. So that means the side that is not touching the right angle. We can see that the box here says that this is the right angle. There's 90 degrees here. This side is touching it, and this side is touching it. So the side that's not touching it is the side AC, and that therefore is the hypotenuse. And in this case, the hypotenuse measures 8 centimetres. Let's try it once more. On this triangle, which side of the three sides of the triangle is the hypotenuse? It's the side AC, this side here. It's not touching the right angle, it's opposite the right angle. So let's learn how we construct such a triangle. we do something that we haven't yet done before with triangles, and that is that we don't always pick the largest side that we've been given as the base or the bottom of our triangle. We have to pick a side that has the right angle attached to it as our base. Let's have a look. So we're constructing a right angle triangle when we have been given the length of the hypotenuse and one other side. In this case, we're asked to construct a triangle with the 3 points at its vertices D, E and F, where the measurement of the side from D to E is 8 centimetres. There is a 90-degree angle, so a right angle, at the point D. Remember that when we have the measure of the angle E to D to F, it's the middle letter, so D, where the 90 degrees, where the angle sits. And we're told that the measurement of the side from E to F is 10 centimetres. Now, in previous constructions of triangles, we may have chosen EF, the largest side that we've been given, as the base. But in this case, as we know that we have a right angle, we have to pick a base side that has the letter D in it, where the angle sits. This largest side, EF, does not contain the letter D. So that means that we will have to use this side length, DE, as our base, because it does have the letter D where the right angle 90 degrees sits. As always, we start off drawing a rough sketch of the triangle. And it might look something like this. Again, we'll try to do it slightly neater than this, but this is just to demonstrate that it doesn't have to be accurate. Your sketch is there just for guidance. And we have decided that we need the base of our triangle to be DE because we need the right angle at the bottom of our triangle. We know that the 90 degrees sits at D, and that means that these will be perpendicular to each other. It will look something like this, and therefore we can quite easily see that the side opposite must be from F to E, and that's the hypotenuse that we're told is 10 centimetres. So this construction really is helped out by having this sketch done beforehand. Once we have actually got our sketch, then the construction of this triangle is very similar to ones we have done before. We start off by drawing our base of our triangle, and we know that that is the side length DE, and it needs to measure 8 centimetres. So we're going to use our ruler to create the base DE. Remember that we must always have all 3 points labelled, and anything that was given in the question, any measurements, also must appear in our diagram. So we write 8 centimetres. Now we're going to construct the right angle, the 90 degrees. So we know that you could use a set square, or you could use a protractor, where you would line up the centre mark with D, making sure the baseline of our triangle and the baseline of the protractor are exactly on top of each other. Then you see which 0, whether it's the left hand side of the protractor or the right hand side, does the baseline of our triangle go through. And you can see it's going through the 0 on the right. And that's for the numbers in the inside scale. So we count up from 0 until we get to 90, which is directly above D. We place our little mark, move our protractor away, and we line up our straight edge to make sure that the pencil is exactly going through D and through the point that we've just created where 90 degrees is. We make sure it's nice and high. Remember that these are our proof that we have constructed appropriately. We label our 90 degrees, preferably a square box, or the inverted small little corner perpendicular line would be fine. Next, we're going to do the last piece of information, which is the second side we were given, the hypotenuse, and we know that that's a measurement of 10 centimeters. So like we've learned to do with other constructions, we're going to use our compass to make sure that we have a 10 centimeter distance between E and the point that we're going to create, F. It will lie somewhere on this line, and wherever it lies will be where our compass, when it curves around, creates an arc where it intersects. So we open up our compass, make sure the point and the pencil are exactly 10 centimeters apart. We're going to put the point on our E, sweep around, and it will intersect this line that we have vertically drawn from D. If you find that it doesn't intersect, it may simply be that you just haven't drawn this line long enough. So extend it, and you will. You will see that they will cross where it crosses here. This point of intersection is about here, and that becomes our third and final vertex of this triangle, F. Lastly, we make sure that we connect F to E, and make sure that we have all information labeled on the diagram. So we need to write 10 centimeters for the hypotenuse measurement. And that's it. Okay, so let's have a go at doing one ourselves. So construct a triangle, and again, EDF. This time, the measurements of ED is 5 centimeters, and the angle EDF, so sitting at the middle letter D, is 90 degrees. So this is where we see that we have a right angled triangle, and we have a third piece of information, another side length. The measurement of E to F, the line segment EF, is 8 centimeters. So we've got two sides and one angle, but the angle is a right angle. So it's an RHS construction. We start by drawing our sketch. There's our sketch. So because we know that we've got a right angle and that it sits at point D, I need to have a side length that includes D as the base of my triangle. This side length does not include D, it just is 8 E and F, so this cannot be my base of my triangle. Therefore, I'm going to draw the line segment first, ED, as my base, and that's 5 centimeters. We know that the right angle is sitting at D, and therefore we have a perpendicular angle, 90 degrees, from our base up to our third point, our vertex F. Connecting E to F then will mean our third piece of information, our second side, and we can see that that is the hypotenuse. It's opposite the right angle. So our construction will end up looking something like this. So let's get started, and we'll start off by drawing our base line of the triangle ED. Remember then, if you're starting off with this line, you're going to have to leave enough space to draw your construction above it. Constructions are really accurate the bigger that they are, so try to make the most of the space. In an exam, you would really want to use up as much space as possible. I've made sure that my pencil is nice and sharp. I've made sure that my line starts exactly at 0 centimeters on my ruler and ends exactly on 5. We make sure that we label all the information that we've been given. So once we have the base, we're now going to do our right angle, which we know sits at D. So I'm going to use my protractor If it's sitting at D, then I will have to have my center mark located exactly on D, making sure that the baseline of my triangle is exactly underneath the baseline of my protractor. I'm now going to see which scale I'm going to use. This 0 has no baseline passing through it, so I'm not going to be using the inner scale. You can see that this 0 does have the baseline of my triangle passing through it, so this is the scale that I'm going to be using, the outside scale. I'm counting up until we get to 90, and we're going to place a very small accurate marker, being sure that we don't accidentally slip the protractor or move it. Then we can take it away, and we can then connect our point D with that marker and continue up our line beyond it. Remember to make sure that your ruler is placed so that the pencil is connecting with those 2 points. Okay, so I've connected it through, made sure it's nice and accurate, and I've used symbolic notation. This time I've used the little perpendicular L, which we know is exactly the same as if we put a box. It's just another symbolic notation way of showing that something is a right angle, is perpendicular to this side here, horizontal and the vertical, have 90 degrees between them. So the last thing that we need to do is create the line from the line segment from E to F. So F will lie somewhere along here. And we do that by using our compass and opening it up to the measurement which we need. And our hypotenuse is 8 centimeters. So there we can see there's exactly 8 centimeters from the tip of the needle point and the pencil point. So that means from wherever I place the point of this needle down and I curve around, that curve, that arc is always going to be 8 centimeters away from that point. So by placing my point onto E and curving around, creating an arc, we see that it does intersect our perpendicular line that we created already. And that point of intersection then will be our vertex F. The last thing to do then is to connect that point F with our point E, remembering to be as accurate as possible. And then we write on our third piece of information. So we always have 3 points labelled, E, D and F, and we have them in pen. And we always have 3 pieces of information that we were given in the question. The side 5 centimeters, the side 8 centimeters, which is the hypotenuse, and we've used symbolic notation for our angle, the right angle, 90 degrees. I would now like you to reproduce the following steps and construction in your notes copy as an example. Please remember to give a heading, construction 13, and it is an RHS triangle. One last thing before we go. Why can a nose not be 12 inches long? Why? Because that would make it a foot. Thanks for listening. I'll see you in the next video for the next construction.